Good morning, everybody. We have a strange looking constant in the middle of this expression that we're trying to simplify. Now we're trying to take the cube root of all of this and hope that it comes out to be a natural number. We have powers of 3 here. So you may be looking for the largest power of 3 that would be close to this constant. That I think is 3 to the 6th. That's 729, right? So that doesn't look close enough to amount to much, but let's see what we can do by making this observation. And I say this is our only hope. That's the only thing I can think of, is take advantage of this identity right here. Take advantage of this identity. The cubed root of something cubed is the something, right? Okay, and so what we can do is just take a look at the structure here. In order for x cubed to be equal to 3 to the 12th, let's just write it down. X cubed equals 3 to the 12th. I mean, that has to happen or we're nowhere, right? Okay, that implies that x is equal to 3 to the 4th, just properties of exponents. 3 copies of 4 is 12, right? So x is equal to 3 raised to the 4th power, right? Okay, and that, again, so that means x cubed, we're good to go. X cubed is equal to 3 to the 12th. So we've taken care of at least this first term, all right? Now, if you take a look at this second term right here, we know that we need a 2 here, and then this needs to be 3 to the 9th. But notice that's exactly what we get. This is, we'll write 3 to the 1st. It's superfluous, but I'll do it anyway. If you square 3 to the 4th, you get 3 to the 8th, right? So you see you got your 9 here. Here's the 9. 8 plus 1 is 9. Properties of exponents again, just objects, numbers of objects. And then this forces, there's a 2 present. You see we've taken care of 3 to the 9th. The 2 is present right here. So we have to, for this to work, a has to be equal to 2. Okay? So let's keep moving. Now, this part right here, this would be 3 times 3 to the 4th. Again, just using our substitution all the way through. Okay? Now, a squared, if a is 2, a squared would be 4. All right? And then a cubed would be 8. Like that, right? Okay, and so if you try to simplify this, let's see, what do we get? 3 to the 5th. Times 4 minus 8. Okay, now what is this? 3 to the 4th is 81. 3 to the 5th is 243. So you would have 243 times 4 minus 8. Okay, now 4 times 240 is 7, let's see, 960 and 12. So that would be 960 plus 12 is 972. So we have 972 minus 8 is equal to 964. Okay, so notice though that is the constant that was here. So you see that again, this thing was just designed to work. All right, so this and this line up, right? Okay, so that means that we're in good shape here because we now know that we have this going on. We have this would be equal to x minus a, right? But that would be 3 to the 4th, right? X is 3 to the 4th. 3 to the 4th minus 2. But 3 to the 4th, 3 to the 4th is 81. 81 minus 2 is 79. Y'all, that's supposed to be a 79. So that gets the job done, folks. And again, people just, in fact, this is a homemade problem. I made it up. But it looks like a mysterious problem unless you know that for these things to work out, it has to fit a certain form. So that's kind of a way when you're doing math competitions to kind of psych yourself out. I mean, this looks, if you just look at this a priori, and you don't think of this, you're screwed. You don't have any idea what's going on. But if you use this result, and I think this is the only result that's going to work out to anything, it works out rather nicely actually, just by expanding this out and then sort of equating coefficients, equate or comparing the terms, then making the adjustments. Okay. So anyway, that is the solution, folks. Thank you for viewing.